Hello, everyone, and welcome to today's session. My name is Kamal, and I'm excited to walk you through one of these most fundamental yet misunderstood aspect of modern architecture, the traffic management components. Today, we're going to dive deep into API gateways, reverse proxy, load balancers, and forward proxies. Now, I know these terms might sound a bit intimidating at first, but I promise you, by the end of this session, you'll not only understand what each one of these components does, but also when and why you would use each one. So let's get started. Before we jump right into the specifics of each component, let's take a moment to understand why traffic management matters in the first place. Think about a busy highway system during a rush hour. Without proper traffic management, you would have a chaos, cars bumper to bumper, accidents, and frustrated drivers. Well, in our digital world, it's much of the same. Every day, there's countless requests flowing between clients and servers. And without proper traffic management, our system would quickly become overwhelmed. It would become slow and vulnerable to all sort of issues. Now, that's where these component comes in. They're like the traffic controllers, highway systems, and security checkpoints to our digital infrastructure. Throughout this session, we'll explore how each one of these components works, what problem do they solve, and how do they fit together to create a robust, efficient, and secure system. So let's start with API Gateway. Think of API Gateway as the front door to your house. It's the first point of contact for everyone visiting, and it controls who gets in, what they can do, and how they interact with everything else inside the house. Now, in technical terms, the API Gateway sits between client and the backend services, acting as a single entry point. But what does that actually mean for you? Well, imagine you have a bunch of microservices running behind the scenes. Maybe one handles user authentication, another processes payment, and third manages product inventory. Now, without an API gateway, a client application would need to know about each of these services individually and communicate with them separately. Now, that gets complicated very fast. So the API gateway simplifies all of this. It receives the requests from client and routes them to appropriate backend services. But that's not all. It also handles authentication and authorization, making sure only the right people can access certain function. It can limit how many requests someone can make in a given time. And that's called rate limiting, which prevents abuse or accidental overuse. It can also cache responses to speed things up and transforms data between different formats. Now, a good real world example is Netflix. They have hundreds of microservices powering their platform, but your Netflix application doesn't need to know about all of them. It just talks to their API gateway, which handles all the complexity behind the scene. So why does this matter? Well, without an API gateway, managing security and monitoring and traffic flow across multiple services becomes a nightmare. And it's like having a house with dozens of doors, but no doorman of security system. It'd be chaotic and it would be unsafe. Now, let's talk about reverse proxy. If an API gateway is like a front door of your house, reverse proxy is more like a personal assistant who answers the door, checks who's there, and decide whether to let them in or not. So a reverse proxy sits between the client and one or more backend servers. When a request comes in, the reverse proxy receives it first, and then forwards it to appropriate backend server. When the server responds, the reverse proxy sends that request back to the client. But why would we want this middleman? Well, there's several reasons. First, it hides the detail of your backend servers. from outside world. All the requests appears to be coming from and going to reverse proxy, not your actual servers. So this adds a layer of security. When attackers can't directly target your servers because they don't even know that they exist. Second, reverse proxy can handle SSL and TLS termination. That's just a fancy way of saying they manage the encryption and decryption of HTTPS traffic. This is important because encryption and decryption can be resource intensive. By offloading this work to a reverse proxy, your backend servers can focus on what they do best, which is serving your content. Now, reverse proxy also provides caching capability. If multiple clients request the same content, the reverse proxy can store a copy and serves it directly without bothering the backend server each time. Now, this speeds up significantly. A common example of reverse proxy is Nginx, which is widely used to manage traffic between web client and backend servers. This is like having that efficient personal assistant who makes everything run smoothly behind the scenes.